In this part of our review, we're going to be working with 3 word problems. And these 3 word problems are similar to the 3 that you have for your assignment. Letter A is similar to your number 1, letter B is similar to your number 2, and letter C is similar to your number 3. Before we start, please remember that we've got 3 jobs to do each time that we complete one of these problems, and on your test as well. We've got to, number 1, be able to identify what x is. Number 2, we've got to be able to write an equation. And number 3, we've got to be able to come up with a reasonable answer. So we have to do that for each and every word problem, both now on your assignment and on your summative. So let's start by reading this problem through and seeing what information we have. Christy is 3 years older than Jamie. The sum of their ages is 23. How old is each girl? The first thing I want to highlight is the word sum. This is one of those words that most math tests are going to assume that you already know from all of your work in previous years. The word sum has to do with the answer to an addition problem. So the problem and the people assume that you know you're going to add their ages and get 23. Christy's age plus Jamie's age equals 23. So going back to our first job of having to identify an x, whether you use a triangle or a regular x is fine. Either way. The only information I have here is that about Christy and Jamie's ages is that Christy is 3 years older than Jamie. And I know the total of their ages when I add them. It seems to me that if we make Jamie's age and we're able to find Jamie's age, we should be able then to add 3 to it and get Christy's age. So I'm thinking Jamie's age is going to be our x. Now my second job, job number 2, is to build an equation. I already know that the clue that the problem gave me is that Christy's age plus Jamie's age should equal 23. So I'm setting up just a note to myself above my scale that says Christy plus Jamie should equal 23. I know my equal sign typically goes here. So I am going to set this up with 23 on the right. I'm used to the equals 23 being set up that way. And then we decided that Jamie's age would be 1x, which would make Christy's age the same as Jamie's age plus 3. So I'm going to take that plus 3 and I am going to just make it into a regular number cube 3. Which means if I summarize here, my equation is going to look like 2 x's and a 3 is the same as 23. Jamie's age, sorry, I wanted to highlight Jamie's age, Christy's age will be in yellow. Christy's age is x plus 3. Okay. And together, this is what my equation looks like. Now, what I also want to be able to do is write that as an old-fashioned equation, like a regular one that you might see on the MCAs. So I'm going to make sure that I'm able to identify that this is 2x plus 3 equals 23 before I go ahead and solve. Then I can go back to my own scale and say, I'm going to take 3 off each side. I've got 2x is equal to 20, which means that 1x is equal to 10. So I can say that Jamie is likely 10 years old, which would mean that Christy, who is 3 years older, would have to be 13. I can double check if I'm correct because the problem told me if I add up their ages, I should get 23. 10 plus 13 is 23. And since this equation got me here, it looks like I successfully did 1, 2, and 3. Moving along to number 2, we've got one that's kind of similar. Jose is 3 years older than twice his little brother Benjamin. The word twice, here's another word that they believe that you know. If something happens twice, that means it happens 2 times. So in math, that means we're usually going to double something, multiply it by 2, or double what is already there. Together, their ages add up to 15. How old is each boy? So what I want to think through is how I'm going to calculate each boy. That'll help me with my x. It looks like, similar to the last problem, Jose's age is only able to be calculated if we first get Benjamin's age. If we get Benjamin's age, we can double his age and add 3 and get Jose's age. So the most basic thing we're looking for would be our x, which would be, I'm just going to put B's age. I don't want to write the whole name if I don't have to. So Benjamin's age is going to be x. I know this because when I look at Jose's age, in order to calculate it, I need Benjamin's age first. That is usually a signal that Benjamin's age will be the thing that I'm looking for, or my x. Now I've got to set up an equation that makes sense. Last time we were talking about their ages adding up together, giving us a signal that that is probably going to be the sum that most people put on the right. Either way is fine. So together we should be able to add Jose's age plus Benjamin's age and get 15. I'm actually going to pull a little switch and I'm going to list Benjamin's age first because Benjamin's age is easy. It's just a single x. Now Jose's age requires that we take Benjamin's age twice, so that would be like 2 of Benjamin's age, and then add 3. If we highlight, we've got, we've got, this is Benjamin's age, and this whole statement here, twice Benjamin's age, and then 3 years older than that, that's Jose. So now if I combine what I've got, it looks like I have a grand total of 3 x's and a 3 with a 15 over here. So I could summarize this in more traditional algebra by saying 3x plus 3 equals 15. Now I'm going to go ahead and solve so I can figure out each of their ages. I'm going to take 3 off each side. 3x is equal to 12, which makes x equal to 4. So Benjamin, here's my part 3. Benjamin is 4. And now Jose, I've got to use the information they gave me. Jose is 3 years older than twice his little brother Benjamin. So if we take twice of Benjamin's age, that would mean doubling Benjamin's age, we would have 8. But then we still have to add 3 years to that, which makes Jose 11. Now, if we are correct, what they're telling us is that together their ages should add up to 15. 4 plus 11 is 15. The two age problems we had were different and unique, and those tend to be a little bit more difficult for students to understand. This has to do with purchasing things, which is what people are usually good at. Let's read through this one. Carmen had $10 and her sister gave her $10 for her birthday. She used all her money to buy 2 burgers and 2 shakes. If the shakes were $3 each, how much did each burger cost? So our first job is going to be establishing what our x is in this problem. In this problem, it's very easy what our x is because it asks us to find how much did each burger cost. A question like that sets us up to say that our x should be the cost of 1 burger. Now our equation has to match the situation. So the first thing that I think about is how much money Carmen had. And it says that Carmen had $10 and then her sister gave her $10 more. So it looks like if I were to summarize, Carmen had a total of $20. Now, Carmen also, if we think about this is how much she spent, right? This would be her total on the left. Typically on the right, we're going to have to talk about what she bought. So let's see if we can come up with a system for showing what Carmen bought. She bought 2 burgers and 2 shakes. We know we're looking for the cost of a burger, and since she bought 2, I'm going to put 2 X's there. And the shakes were $3 each. She bought 2 of them, so I'm going to say she spent $6 on her shakes. If I update this, it looks like 2x plus 6. If I write it more traditionally, this equation would look like 20 equals 2x plus 6. And now to solve, I'm going to go back, take 6 off each side. 14 is equal to 2x, which makes x equal to 7. So each burger was $7. Now you go and take the 3 word problems that you've got for your assignment and try them on your own.